Hello students, welcome to the video lecture series. In this video, we are going to discuss about Johannes Kepler and his three laws of planetary motion. Johannes Kepler was well-known astronomer in the 16th century who developed three laws of planetary motion. Before we start discussing about Kepler's laws of planetary motion, let us know a little bit of history. So before Kepler's laws, there are two theories about planetary motion. First one is geocentric theory. Geocentric theory was proposed by Greek physicist and mathematician Ptolemy. According to this theory, Earth is at the center of the universe. Planets, sun and star are revolving around the Earth in a circular orbit. So why circular orbit? Because that time circle was considered as perfect shape, and if God created the universe, obviously the natural shape would be circular shape. And this theory is believed by people for almost 1500 years. And then came Nikolai Copernicus. He proposed heliocentric theory. And according to heliocentric theory, sun is at the center of the universe and all other heavenly bodies like planet, earth and star are revolving around the sun. And in this theory also, the shape of the orbit is still circular. The shape of the orbit is still circular. And then came Danish astronomer Tycho Brahe. He spent his entire life to observe and collect precise data about planetary motion. But he still believed in heliocentric theory. And then comes Johannes Kepler. So Johannes Kepler used the data collected by Tycho Brahe to understand the planetary motion. And by careful mathematical analysis of the data, he proposed three laws of planetary motion. The first law of planetary motion, also known as law of orbit, it states that each planet moves around the sun in an elliptical path, not circular path, in an elliptical path with sun at one of the foci. So in this theory, the planets are revolving around the sun in an elliptical path where sun is at one of the foci. So this is the first law, that is also called as law of orbits. So planet is revolving around the sun in elliptical path. So for this ellipse we have two axes. One is called as major axis, that is P to A, that is called as major axis, and another one is B to C, that is called as minor axis. And half of the major axis is called as semi-major axis and half of the minor axis is called as semi-minor axis. And then there are 2 points here. One is nearest to the sun is called perihelion and other one is farthest from the sun called aphelion. So this is the law of orbits. So according to this law, planets are revolving around the sun in an elliptical path. Now the second law of planetary motion, also known as law of areas. It states that the line joining the sun and the planet sweeps out equal areas in equal intervals of time. According to this law, the line which joins the sun and the planet sweeps out equal areas if same interval of time is given, irrespective with their position. Okay? That means the planet is sweeping out equal areas in equal interval of time. And this law comes from the observation that the planet moves faster when it is closer to the sun and slower when it is away from the sun. That means when planet is near to the sun, its velocity or its speed increases, and when it starts to move away from the sun, its speed starts to decrease. And that's why the planet's velocity at perihelion is maximum and the planet's velocity at aphelion is minimum. And this law, that is the law of areas, is the consequence of law of conservation of angular momentum. That means the angular momentum of the planet is always remains constant. It always remains constant. Now Kepler's third law of planetary motion, that is also called as law of periods. It states that the square of the time period of the planet is directly proportional to the cube of semi-major axis of the elliptical path. According to this law of periods, if the planet is revolving around the sun in an elliptical path, if it takes t as its time period to complete its one revolution around the sun, and if a is its semi-major axis, we know that 2a is called as major axis and a is called as semi-major axis. And then according to this law, this t square is directly proportional to a cube. If t is time period of the planet and a is semi-major axis, then t square is proportional to a cube. And if you want to go further, then you will get one constant, proportionality constant, that is k, and into a cube. Okay, so this is according to the law of periods. T square is directly proportional to a cube. And now if T1 and T2 be the time periods of the two planets, if you are considering two planets, then T1 is time period of the first planet, T2 is time period of the second planet, and whose semi-major axis is A1 and A2 respectively. A1 is semi-major axis of the first planet, A2 is semi-major axis of the second planet. Then we are going to get this equation from this relation, that is T1 by T2 square is equals to A1 by A2 whole cube. Okay, A1 by A2 to the power 3. Okay, so this is the law of periods.